the last video of AI data processing pipeline, we experienced how to deal with different kinds of data and make it model ready. In today's video, we would be seeing how to utilize that data for model training and then how to use the trained model for predictions or inference. For this, we would be focusing on image data, that is fashion MNIST data. The model would be a simple four-layered CNN architecture. Everything that would be done through code would be explained visually over here with an interactive dashboard created by me. So let's begin. So usually when we train a model, we first create a model. Over here, the architecture consists of four convolutional layers. So for each convolutional layers, we can define the number of channels for those layers. The last layer is a fully connected layer which connects the convolutional 4 layer with the 10 outputs that it needs to predict. Whenever we train a model, we set these model hyperparameters. Apart from that, we also set the training parameters like number of epochs, batch size, and optimizer. So usually when we do training, we try to train on multiple architectures using multiple hyperparameters so that we can experiment and see which one is giving better results. So over here we are trying to mimic the same thing. We have over here two different models. They're different because the number of channels in each of the convolutional layer is different. Then we'll try to set different hyperparameters for training and observe the results for the training and validation. So over here, both the models would be trained sequentially one after the other. First model 1 will be trained and then model 2. So once the model training starts, we can see its log over here in the dashboard itself. So for each epoch, whenever both the training and validation gets completed, the result of it will be updated in the plot dynamically. So over here we can see 4 points, two for trained data and two for validation data. And for trained data, we can see the training accuracy and the training loss. For validation data, we can see the validation accuracy and the validation loss. So as each epoch gets completed, its results get plotted in the graph. So within the model 1 training, we can compare the training and validation results over here in the same graph. So once model 1 training gets completed, model 2 training starts. So now we can visualize the results of model 2 as well in the same graph so that we can compare the performance of both model 1 and model 2. So right now we can see both model 1 and model two's performance. Once the training ends, the inference tab gets enabled and the inferencing starts for 10 random images for all classes. So during inferencing, the best model is selected. So the best model is determined by whichever one is having the maximum accuracy on the last epoch. So over here in the inferencing results, we can see the total number of images inferenced, the number of correct predictions and incorrect predictions. And for each image, we can see the original image that was passed into the network and the GradCam results for the same image for the last convolutional layer. So basically, the GradCam layer tells on what portion of the image the network focuses on to determine the class of the image. So over here, we can also see the actual ground truth and the predictions made by the model, along with the confidence with which it is making that prediction. So over here, we can play with the two models. We can select any models, and for those model, we can select any classes and see its result with any number of images. We can also select the correctly or misclassified images and see the GradCam results for all the four convolutional layers as well. So for each image, we would see the GradCam outputs for each of the convolutional layers. Usually, the GradCam helps in identifying the issues in the model where misclassification happens. So, this is the entire flow of training and inferencing that is usually done in the pipeline.